Heat versus temperature. Heat and temperature are two words that we sort of use similarly, but they mean slightly different things. Heat is the total amount of thermal energy in a substance. If you imagine that all of the substances that we think of are made up of tiny particles, and those particles are constantly in motion, then heat is the kinetic energy associated with the motion of those particles. Now, this is a little misleading because these motions or these vibrations in a solid are so small that we can't observe them, and so we might think as we look at an object that it's not moving, and so the idea of having kinetic energy associated with that motion is a little confusing, but it all comes back to the idea that if a solid is made up of these tiny particles that we can't see, I guess it's not that hard to believe that we can't see their movement either. Temperature. Temperature is a measure of the average velocity of the particles that make up a substance. So, an object with a higher temperature has particles that are moving faster than an object with a lower temperature. When we look at all the particles that make up a substance, and we imagine them, if we have the number of particles on this axis, and the speed of the particles on this axis, there's a typical curve that results. That curve is called the Maxwell-Boltzmann distribution. So there's some most likely speed, and there's some average speed, and so most of the particles would be at this speed. There'd be less particles at this speed or at this speed. As we heat up an object, not every particle in that substance moves faster. What happens instead is that the distribution of particles that makes up the substance shifts. So if we heated this up, what would happen is that we would find more particles at faster speeds and less particles at slower speeds. It does not mean every particle in the substance moves faster. It's just if you take a particle at random from the substance, it would be more likely to be moving fast if the object was hot than if it was cold. So this is T2. If we imagine this as T1, then what we would be saying here is that T2 is greater than T1, or T2 is a higher temperature. Obviously, these two concepts are connected. The higher your temperature, the more thermal energy you have. But we have to remember that there's more than one factor that goes into determining how much energy something has. The energy isn't just based on the temperature. The energy would also be based on the mass of the substance and the type of substance. For example, if you wanted to heat a bathtub, a teacup with 100-degree water in it wouldn't work as well as a giant bucket of water at 50 degrees Celsius. See, the little teacup at 100 degrees Celsius, while it's very hot, the individual particles are moving very fast. There aren't very many of them. So if we imagine the total energy associated with that, even though we have fast particles, we don't have enough particles to make up a bit large amount of energy. Alternatively, the bucket, while the individual particles are not moving as fast, the greater number of them makes up for that, and overall we have more energy. The analogy here that makes some sort of sense is, would you rather have like 10 $100 bills or 150 $50 bills? The $150 bills would be worth $5,000, but the 10 $100 will only be worth $1,000. So even though the individual particles in the $100 bills are a little faster or a little more valuable, the amount of them that you have, or the mass, is important. Also, since it takes different amounts of energy for different types of substances to change their temperatures, the type of substance plays an important role as well. When we make a formula for heat, which is often called Q, keep in mind that this is heat, we say that it is equal to the mass of the substance times C, C being the specific heat capacity. This takes into account different types of substances requiring different amounts of energy to raise their temperature. So the specific heat capacity is the amount of energy required to raise 1 kilogram by 1 degree Celsius. So something like water would require about 4,200 joules, where something like iron would only require about 700 joules. So this is very different depending on the types of substances. So the amount of heat or the amount of energy is equal to the mass times the specific heat, so that's taking into account the type of substance, times the change in temperature. So how many particles, what kind of particles, and how fast they're moving. Temperature, on the other hand, simply represents how fast the particles are moving without considering any of those other factors.